The next section, 8.3, talks about quotients of square roots. When we are dealing with square roots, you may never leave a square root in the denominator of a fraction. So this example right here, 2 over the square root of 13, that would always be marked as wrong because we need to rationalize our fractions. And so this process of removing a radical from the denominator is called rationalizing. And this is the process that we are going to use. To rationalize the denominator of a fraction, we multiply both the numerator and the denominator by the square root that you see in the denominator. So let's look at an example. In our first one here, we have square root of 3 over square root of 2. If we multiply our top and bottom by square root of 2, on the bottom, we have square root of 2 times square root of 2. Every time, that is going to eliminate our square root because we have the square root of 2 times 2 on the bottom now and square root of 2 times 3 on the top. That gives us square root of 2 times 3 is 6, and on the bottom, square root of 4. Now, square root of 4 we know is 2, and we have the square root of 6 on top. So this new fraction has been rationalized because we got rid of the square root in the denominator. Okay, let's do a few more. Number 2, if we have the square root of 6 on the bottom, we need to remove that by multiplying by square root of 6 on top and bottom. On the top, we get square root of 5 times 6. And on the bottom, we have the square root of 6 times 6. On the top, 5 times 6 gives us 30. And on the bottom, you can either multiply that 6 times 6 and get 36, and then know that the square root of 36 is 6. Or you can see we got a pair of 6's, so that 6 is going to come out, and there's nothing left under the square root. Either way, you're going to get 6, whichever makes more sense for how you think about it. Okay, we're going to take our next one, multiply by square root of 7 on the top and bottom. And remember, all we're doing here, when we do that, multiply by square root of 7 over 7, we're just multiplying by 1. So we know our fractions are going to be the same number, but now it's going to be rationalized with the square root only on the top. Here, be careful, our 6 is not under a square root, so on top we have 6 times the square root of 7. On the bottom, square root of 7 times 7, and we get 6 square root of 7 over 7 times 7 is 49, square root of 49 is 7. Or you take that pair of 7's and you know you can pull 1 out and you have nothing left under the square root. Okay, there's a few more examples. We're doing the same thing on all these examples. Multiply by the square root of the denominator. Here we get 8 times the square root of 2 over square root of 2 times 2. Which we get 8 square root of 2 over 2. 8 divided by 2, we know that is 4. So we have the 4 times the square root of 2. In our next one, we're multiplying by the square root of 2 again. This time the 8 is under that square root, so we can combine them. We have 8 times 2 under the square root. And then square root of 2 times 2 on the bottom. 8 times 2 is 16. And square root of 2 times 2 is 4. Square root of 4 is 2. we know the square root of 16 is 4, because 4 times 4 gives us 16. So we have 4 over 2. 4 divided by 2 gives us 2. Okay, number 6. Multiply by the square root of 3. Because that is what's on our denominator, that's what we're trying to get rid of. We're combining only what's under the square root on the top, so we have 2 times 7 times 3 on the top, and then square root of 3 times 3 on the bottom, 2 square root of 21 over 3 times 3 is square root of 9, 2 square root 21 over 3 is our final answer. Okay, number 7. There is no square root on the bottom of our fraction, so it is already rationalized. But there is one thing we could do to simplify. We have 6 divided by 2, so we know that this equals 3 square root of 5, because we can divide that 6 divided by 2 right there. Our last one, we have a square root of 2 on the bottom. We need to multiply square root of 2. On the top, I have 10 times 2, which is 20. And on the bottom, I have 2 times 2, which is 4. Square root of 20 over 2. Now I can keep going here because my 20, even though it's not a perfect square, I can still split 20. I know 20 is 2 times 10. 10 is 2 times 5. And here I have square root of 2 times 2 times 5. I can pull out one of those 2's. If I have a pair of 2's right there, it's the same thing as 2, and only the 5 is left under the square root. Now I have 2 divided by 2. My 2's go to 1. 2 divided by 2 is 1. And I have the square root of 5 left as my answer.